Assalamu alaikum students. So here we are having a third lecture from same quantitative reasoning one on exponents. So what are exponents? Exponents are basically numbers that have repeated multiplication. For instance, if I'm given a certain number which is written many times, in this case I'm writing 2 4 times, or I can say that 2 is multiplied by itself 4 times. So since this number is written 4 times, 1, 2, 3, 4, I can equally write it as 2 power 4 or 2 with the exponent 4. Here 4 is exponent, or we can say that 4 is the power over the base 2. In this case 2 is the base and 4 is its power. Let's move to the next slide. At the end of the lecture, students would be able to cover integer exponents and its properties. They would be able to use scientific notations. They would be able to convert scientific notations to decimal and back to scientific notations again. So this is the formal book definition that in a real number, if a variable is repeated many times with the multiplication sign, or if a variable is written with the product sign many times, so that variable would become the base. As in this case, the base is a, which is repeated many times, and since it is written n times, so n is its power, or n is the exponent over the base a. Okay, here we have several examples. As in the first example, you can see that 7 is written twice. 7 is multiplied by itself twice. So we can say that 7 is having power 2, or 7 is having exponent 2. In the next example, a is written 5 times. A is multiplied by itself 5 times. So 5 has become the exponent over the base a. In the third example, you can see that minus 4 is multiplied thrice by itself. So minus 4 is the base and 3 is its exponent, or 3 is the power over the base minus 4. In the last example, you can see that 2x is written 4 times. So 2x is the base, and since it is multiplied by itself 4 times, so 4 is the power over the base 2x. In the next slide, you can see there are various properties of exponents given. The first says if we have two, let me show pointer here. If we have two same bases in the product sign with different powers, we will write the base once and we'll add these two powers. Look at the example. Over here, the first number is 3 square and the next is 3 power 4. So here the base would be written once. The base would be written once, and it's both the powers would be written in the with addition. So that means it would become 3 to the 3 power 6, or 3 with the exponent 6. The next rule says that whenever two bases are in the quotient form, the power in the denominator would change its sign. as in this case. Here you can see that the first in the numerator is a power m, and in the denominator we have a power n. Over here the base is same but powers are different. So we'll always shift this power in the numerator. In the denominator it has plus sign, so when it is moved in the numerator it would alter its sign, and we'll write it as a m minus n. So powers have difference in relation. The example is shown. This is also known as quotient of powers. In the fraction we have x7 divided by x4. So since 4 is positive in the denominator, and when we applied the rule of quotient of power, 4 is shifted in the numerator and it has altered its sign, and we'll simplify the powers, and finally we have got x cube. The next rule says that whenever two different bases are in the product form and they have some common power, we'll always distribute this common power equally to both the bases. In this case we have two different bases inside the bracket, so we'll shift, or we'll put this power m on both the bases equally. The example illustrates that 5x is having power cube. Since 5 and x are two different bases and they have the same common power, which is 3, so according to the rules and properties of exponents, we'll put this power 3 on both the bases equally. We'll see if the power is simplified. In this case we'll find cube of 5, which is 125, and we'll produce the final answer. This is known as power of a product. The next rule says that whenever two different bases are in the quotient form and they have the same power over them, again we'll provide the same power to both the bases equally. Example, 2 over x whole power 3. So since 3 is the common power, we'll put this power over 2 and we'll put this power over x, and we'll simplify. The final answer is 8 over x cube. This is known as power of a quotient. The next rule says that whenever a base has two different powers, or we can say that whenever a base with power is having another power, so in this case power would be multiplied with power. Don't add power by power. We always multiply whenever we have two different powers over the single base. You can see in the example, y is the common base with two different powers. Inside the bracket it's 3 and outside the bracket it's minus 4. Students might mistaken and they take the difference of powers. So you have to remember the rule. When the base is single and it has two different powers, we'll always multiply power by power and we'll produce the final answer. This is known as power of a power. The next rule says that whenever the base has negative power, we always shift its position to try to produce the power in the positive format. Over here in property 6, you can see that n is having negative power in the numerator. So we'll change its position. We'll write it in the denominator with the positive power n. Similarly, if the power was negative in the denominator, we had shifted it into the numerator to make the power positive. This is known as definition of a negative power. Then we have 0 over some base. Whenever we have a huge base or a small base with 0 as a power, that would be entirely equal to 1, because 0 power makes the entire function equal to 1. This is known as definition of zero exponent. In the example, you can see that inside the bracket we have two different terms, but over the bracket the power is 0. So since the power is 0, the entire function would be equal to 1. Okay, here we have few practice questions. Here you can see that the base is having the negative power. So recalling the definition of a negative power, we'll change its position. We'll write x in the denominator to make it positive. Again, in the next question, there are two terms, 3 and x negative 2 in the denominator. So since 3 is positive, we'll keep 3 as it is at its place and we'll only shift this x negative 2 in the numerator to make it positive. We will keep numbers 1 and 3 at their own places and we'll only move the base which is having negative power. So in this case, x is having negative power, so we'll only move x in the numerator to make it positive. Right. In the next question, we can see that this is a little bit complex question where the numerator has many terms, a coefficient which is 12, two bases with different powers, and in the denominator we can see similar bases with different powers. So over here we'll try to solve numbers first. We see that if 12 and 4 are divisible, as in this case 12 and 4 are divisible by 4 itself. So 12 divided by 4 is 3. So we have divided them both. Then we have moved the bases with the negative power. Over here a is negative 2, a is having negative 2. So we'll move this a in the numerator to make it positive. Similarly, b is having negative power in the numerator, so we'll shift b downward in the denominator to make it positive. Likewise, we can see that both the bases are alike. So here we can recall that here the bases are same in product, so powers would be added. So a cube and a square would be added to become 5. Similarly, in the denominator, b is the same base with two different powers. So we'll add the power, recalling the first rule and first property of exponent. So this is the final answer. One question is given for your practices. I hope you would remember all the rules of exponents. You would practice them and you would be able to solve this given practice question. Here are several questions given for practices and let's solve few of them over here. Let's take number 2 first. Here we have two different bases written in the product sign. We have two same bases with two different powers. So recalling the first property, here we don't have to mention the property, we just have to recall the rule and have to produce the final answer. Since the bases are same in product sign, we write the base once and we'll add the power. This is the answer to question number 2. Let's do one more. Let's solve question number 10. In question number 10, you can see that we have, let me write the question first. This is 6 to power minus 3. And then we have 3 power minus 1. Here dot indicates that the numbers are written with product sign. This dot is also a product sign. So let's solve them now. So recalling the rule of a negative power, we have to move negative number with negative power to make the power positive. So here numerator, in the numerator we have 2 minus 3 and 3 minus 1. So we'll move 2 in the denominator and make it positive. Similarly, we'll move 3 in the denominator to make it positive. Now since the powers are positive, we'll see if we can solve them. 2 power 3 is 8 and then we have 3. So now we have simplified and can see that these numbers can be solved further. So this is now 6 over 24. We'll solve these both numbers and we'll see that the numbers are simplified and we have got 1 over 4 as an answer. So I hope these all questions are very well understood. Let's move to the next slide. Okay, in this question from 21 to 24, you people are required to evaluate the value of the expression after simplifying them. So let's see question number 22 first. In question number 22, we are given 4x minus 3. So students, you can see that the power over the base is negative. So we'll make it positive first. We see if these are being simplified here. So 4 and x cube cannot be simplified because 4 is a number and x is a variable. We'll see the next given. In question number 22, they say that the value of x is 2. So now over here you have to put value of x in place of x. So over here x is 2. So we'll put 2 in place of x and we now simplify its power. So this would be 4 over 8 because 2 power cube is 8, and we'll see that if these two are divisible. So yes, these two are divisible. We'll solve them and over here the final answer is equal to 1 upon 2. I hope you would be able to solve the rest of the given questions. Moving to the next slide. Alright, now we are on the slide where we are given a number which is too large or a number which is too small. So here in this case that they have given an example that human body is having 100 trillion cells. So it's difficult to remember so many zeros over here. You can see that there are plenty of zeros after 1. So we cannot remember these zeros. So what's the other way to remember such a large figure? And in the next example, they have given the mass of dust particles. Again, this is just a mass of one single particle. What if we have plenty of dust particles? We can see that this is like there are many dust particles in our environment. So what if we have like multiple of these particles? So how to remember such a large number of set or such small mass with so many of numbers after decimal sign? So for these cases we have scientific notations. So scientific notations are used whenever the given number is too small or too large. Given an example, after 1 we have 3 zeros. This is a big number, huge number. It has its value and this is greater than 1. So we'll write it in the form of a scientific notation by moving a decimal number left towards the first non-zero number, which is 1 in this case. Let me show you how. Here you cannot see decimal. That's understood that decimal is after the last digit, which is 0. So we need to move this decimal to the first non-zero number, which is 1 in our case. So decimal has to move leftward 3 places. So because I moved decimal 3 places leftward, I'll put 3 as an exponent to the base 10, which is equal to 1000. Or you can remember that this in a way that 1000 is greater than 1. That's why the power is positive. Same happens with another example of 10,000. Over here we have 4 zeros after the decimal, before the decimal. So we'll move decimal to the first non-zero number, which is 1. And in this case again the decimal In this case, decimal has to move 4 places to reach first non-zero number, which is 1. So here the power is 4 over base 10. Okay, seeing few more examples. In this case, now this number is too small because the number is given in decimals. After decimal we have 4 zeros and 1, so this is very small number, very smaller than 1. So in this case power would be negative. Again, decimal has to move 5 places to reach the first non-zero number, which is 1. So because decimal has moved 5 places rightward, the base would have negative power in this case. In the next question, again, decimal has to move 7 places to reach the first non-zero number, which is 7. So again in this case, decimal would be, since decimal is moving rightward, the number is smaller than 1. So in this case also the power would be negative. I hope this is understood. Now few questions are given for your practices. Please solve them, recalling all the rules. Thank you.